Okay, so here we go, 4.3. Is that dinner, Manuel? I got one of those sitting in my office. All right, so two equations with two letters. That's the name of the game for the night. Is that what you were expecting? No. Wake up this morning thinking two equations, two letters. So two equations, two letters. How do we solve when there's two equations and two letters? Have you done that before? Sometimes some other algebra class maybe? A little review for some of you. So what do we do? There's a couple of techniques. Anybody know one?
Put them together.
Yeah, basically all the techniques end up getting rid of one of the letters one way or the other. That's totally the name of the game. Basically, yeah, that's really it. We don't want both letters. We can't really deal with X and Y. We have to get rid of one of them. So how do we do that? How are we going to get rid of one of those letters? Because two of them is too much. We need to get down to just one letter. How are we going to get rid of one of those? That's a great idea. That's the name of this section. Yeah, I don't know if you noticed, I'm doing things kind of backwards on the syllabus. I mean, not only am I doing chapter 4 before chapter 3, that's a little backwards, but then I'm going 4.3 followed by 4.2. I'm doing those backwards, just trying to give you guys a little bigger challenge. No, I'm kidding. I think it's easier actually this way. So I want to do 4.3 first. I think we really get 4.3 down. Then when we back up to 4.2, it's the same stuff. And I'll say, hey, if you have any trouble with it, just do it the old way. So that's the plan. So 4.3 is called the addition method. Addition method. It's also called the elimination. It has two names. Goes by either name, AKA, also known as the elimination method. So you can call it either one you want. So what is it we're going to do? We're going to add, just like you were saying, we're going to add these two together. It's like OSHA, right? OSHA was saying, we're just going to add these two together. So straight up and down. So here we go. 5x and 6x. Just adding straight up and down. What's going to happen there? 5x and 6x? 11x. Positive y and negative y? Cancel. 0, huh? They're gone. You write 0 if you want, or just nothing, whatever. 20 and 13? 33. So, makes sense so far? I just added straight up and down. Just boom, boom, boom. What happened?
We get rid of one.
Y went away. That's excellent. That's exactly what we wanted, right? We wanted one of the letters to drop out. Y did. It dropped out. So now we can, let me just get that 0 out of the way. We can solve for x. Now that we have only one letter, it's way better, isn't it? It's way better to have only one letter than two. How are you going to solve there for x?
Divide.
Yeah.
Divide 11.
Yeah, because that 11 is multiplied by the x on. Last step is always divide. Exactly right. So divide by 11. Boom. X is 3. X is 3. Are we done? Almost. We have to also get an answer for y. So they want us to give an answer for y. How are we going to get an answer for y?
We plug the value. X.
Yeah. Now we're going to take that answer, exactly right. We're going to take this and we're going to plug in x equals 3. So when you get the first answer, you get the x equals 3. You take that and you plug it in. Where do I plug it in? Either one, really. It doesn't matter. You can plug into the first one or the second one. It'll actually be the same in either one. It'll work out exactly the same in either one. So I'm just going to go up there to say that first one. So I'll bring down the first one here, which is 5x plus y equals 20. And I'll take that 3 and I'll plug it in right there for x. Are we good with that so far? All right, so now what's going to happen from here? I'm going to get 5 times 3 plus y is 20. That's 15 plus y is 20. And how do we get y alone? Last step here. Just subtract, huh? Just subtract the 15 from both sides. Boom. Y is 5. We are done. We got x, we got y. X is 3, y is 5.
The answer is 5.
What's that?
The answer?
You had a different problem? I think.
Oh, maybe.
Yeah, it makes different ones for everybody. Yeah, ours is right. Ours is right. I'm not sure. Let's see how they want us to answer. What they want you to say is 3, 5. Whoops, let me kind of scribbly there. 3, 5 with parentheses and a comma. Everybody says, so this final answer is x, y. They want parentheses with a comma. That's called an ordered pair. Whenever you see the words ordered pair, you write that. Ordered pair. That's what they want. They want the x, the y. 3, 5. And we're done. Now, was that good questions I can answer on that one? So just our first one. Was that making some sense?
Yeah.
How we doing? So, how can we check if that answer's right? Is 3, 5 really the right answer? Yeah, it's supposed to make both equations true. That's what this is supposed to be. The x being 3, it's x, y. It's always alphabetical. X first, then y. So the x and the y plugged in, x3, y5, is supposed to make both of them true, does it? If I put 3 in for x here, you don't have, this is not required. And 5 in for y in both places, you see y. Does it make it true? Is that right? 5 times 3? 15 plus 5? 20, huh? And 6 times 3? 18 minus 5? 13. See how that x and y make both equations true at the same time? Don't they? Is that good? Does everybody see what we did there? Questions on that? All right. Okay, so there's number 2. You want to copy that one down. And we'll do this one, which is a little bit harder. Okay. All right. Now, let me do what we did last time, and we'll see that it actually doesn't work. So don't write this down. Just watch me do something dumb right now, but learn from it. Right? So what if I try to do on this one what I just did on the last one? It won't work. So don't write this down. Watch. If I just draw this line and just go plus, and I just go, straight up and down, 3x and 4x, 7x, 3y and minus, that's really a 1 there, huh? 3y and minus 1y, what's that? 2y plus 2y. And minus 4 and minus 40, what's that? Minus 44. Okay, that didn't work. Now, what do I mean that didn't work? It added just fine. What's my problem? Yeah, you need one of the letters to cancel, right? This is called the elimination method. It's also called the addition method. In other words, when you add them, something should eliminate. That's why it goes by both names. So something should have eliminated and nothing did. So what do you do then? I tried it, it just didn't work. What can we do? What? Yeah, you got to make them be the same number. One negative, one positive. Opposites, really. So that when you add them, they will drop out, huh? So before you add, you've got to make them be opposites. Either the x's or the y's. It doesn't really matter which one. You can do either one. There's a lot of freedom here. You can do a lot of different things. So I'm just going to do the y's because that's what we did last time. It looks easy. If I make that a minus 3y before I add, and then add, then the y's will drop out. Now, what do I mean, make that a minus 3y? Does that sound kind of weird? Can I just like come in here with my eraser and say, now you're a minus 3y?
If you want to get rid of y,
Is that okay? And then add them up, and the y's will go away?
You multiply the top equation by 3
Why? Why can't I just do it this way?
because it doesn't cancel anything.
Because what?
It's not going to cancel anything.
It's not. If I add them up, 7x, the y's will go away. Minus 44. Seem to work beautifully. Why? That's not right, is it?
Because it's changing what the actual equation is.
Right. Everybody know why that's not okay? I think that's important to know why that's not okay. That'll help you remember this stuff, rather than if it's just like rules Mr. Heron said, you know. That changed the problem, didn't it? Whenever now you might think, well, we change problems all the time. Yeah, but we change them in ways that don't really change them. In other words, we change the way they look without changing their actual values. Does that make sense? So if I'm going to mess with that equation in any way, shape, or form, I've got to make sure I do it legally. What do I mean legally? Whatever you do to one side, you have to do the other. You have to do all the way across. That way nothing's really changed, right? If two things are equal and you treat them the same, they're going to be equal afterwards, even if they look different. Right? That's the principle. So whenever we mess with an equation, we got to do the same thing to both sides, or we've changed the problem. We can't change the problem. We can change the way it looks, but not change the problem. Yeah, so that's right. So that's why I can't just change that little part right there. Let me put it back the way it was here. Right, so with all that, that's all what we don't do. So what do we do? I'm going to multiply through. So now you can start writing. Here's the right thing. I'm going to multiply through the top equation by 3.
Is it because the 3's on the bottom, the other numbers?
Exactly. Yeah, because I want to make this minus 3y and that plus 3y, so that when I add them, the y's will drop out. Because you got to get those y's to cancel, huh? Is that making sense? But I have to do it equal treatment all the way across, so I don't really change the first equation. Just change the way it looks.
Why wouldn't it just be like, okay, say you're gonna multiply the y by 3. You know how you always say what you do to one side, you do it to the other?
Right.
I would think that you would just do it to the 4 and not the other 3x.
Just do it to this 4 and that.
And
Oh,
not
just
that.
these two
Yeah.
and not that. Good question. I like that. Set of E, right? So let me address her question real quick. Her question's a good one. She's saying, okay, I get your thing, Ms. Taryn, do it to both sides, but why don't you just do it there and there?
I know I wouldn't change the whole equation.
Yeah. So what you want to be clear on? So everybody see her question's a good one. I'm sure other people have the same question. It's a good one. Be clear in your mind. If I said, let me think with numbers with me. If I said 7 equals 7, obviously that's a silly and true statement, and I multiply both sides by like 3, then 21 equals 21. Still equal, right? If they're equal before, treat them the same, still equal. So let's just watch it play out with pure numbers, and you'll see the truth. And now, let me redo that. Instead of writing 7, let me change that. And, I'm going to mess here. Instead of writing 7, let me write it as 5 plus 2. That's still 7 equals 7, right? That's still 7 equals 7, isn't it? Right? That's still true. Now, I'm going to multiply both sides by 3, get 21 and 21, just like I did last time, right? The equal before, 7 equals 7, it's going to be equal afterwards. Multiply that side by 3. Now, what do I do when I multiply the other side? Do I multiply just the 2? See the difference? Because it's the whole side that equals the 7.
Okay.
So you're going to do the whole side. Really good question. Everybody see that? So this whole side equals the right side. Multiply everybody on one side, everybody on the other. That preserves the equality, doesn't it? Good. Please ask. I would always ask my teachers, why this, why not that? I had lists. I think they were afraid to see me coming in the halls. So there's that Heron kid again. That dumb kid. These his lists of questions. So really, I would ask and ask and ask, and then I would understand after lots of asking. All right. So here we go. So I'm going to bring this top equation down. 9x minus 3y is minus 12. So I multiplied through that top equation 3, 3, 3, right? Because it was equal before, treated them the same, going to be equal afterwards. The bottom equation, I'll just bring it down unchanged. I didn't change the bottom. I just want to keep them kind of lined up. I guess you don't really have to, but it might be a little easier to keep everything kind of lined up, you know. So the top equation I multiplied through by 333. The bottom I didn't change it at all. See how I've made these y's opposites on that? Now is the time to add them. Now that the y's are opposites, we can add them. Can you take it from there? So that was the new part. So let me give you a second. So add them up. 13x. These cancel by design. We made that happen. And this side is what? Minus 52. Good there. All right. And then what do we got? We want to get x alone. What do we got to do to get x alone? And divide by the 13. Boom. X is, what is that? Minus 4. So we got x. We're halfway there, really more than halfway, huh? So we have x. We still need y, though. Can you go back and get y now? So go ahead and take this back up here and just use the first equation as it was before we changed it. Or you can do the second one. Really, you can do the third one. It doesn't matter. Use any of them. They'll all work. I'm just going to use the easiest thing possible, which is, I think, that very first one. So I'm going to plug in x equals negative 4 to this top equation here. 3x minus y is negative 4. So I'm going to take that top equation and I'm going to plug in the first answer we got, the negative 4. 4x. So let's do that. So grab this negative 4, plug it in right there. That'll become 3 times negative 4 minus y is minus 4. So we get minus 12 minus 12 minus y is minus 4. We're almost there. What do we got to do to get y alone? Y saying I want to be alone. These loner letters. Add the 12 to both sides. Gonzo. And so now, here's a mistake I see sometimes. People go, y is 8. What's wrong with that?
Minus y.
It's minus y. I lost that minus sign, right? That minus sign is on the y. It's on. That's his baby. And so you got, bless you. How do you got to get rid of that? How do you get rid of that minus sign? You divide, huh? So last step, divide by negative 1. So y is actually negative 8. Can you see that down there? Negative 8, because positive over negative is negative.
Did you state before that you can never end with a negative y?
Yeah, y has to be totally alone, which means not even a negative on it. Yeah, so a negative really means a negative 1. You got to get rid of it, yeah. All right, so now how do you write your answer on these? Yeah, you got to put parentheses. Here, I'll write it over here in the corner. Got to put parentheses, the x answer, comma, the y answer. Negative 4, I don't know if you can see that green over there. Negative 4, comma, negative 8, x, comma, y. Parentheses, comma, there's our answer. You can check it. I'm not going to bother to check it. It would make them both true. You can check all your answers on the next test. At least these kind of problems. We good there? Questions on that one? Yeah. Carlos.
So, on the very top right, when you put 3x minus y equals negative 4,
Right.
you're still multiplying the top by 3, right?
No, I did that just for this. But when I went, good question, Carlos. When I went back to the plug-in step, I said, I'm just going to use it the way it originally was before the 3. You can do that. You can multiply by 3 and then take it back. And then just use it the way it was before. Totally okay. Because both versions are true. Before and after. So I can use either one. That's good. Let's want to try one. So that one's a little harder, right? So what's the name of the game again? You've got to make the y's be the opposites, don't you? Before you add. You've got to make the y's be opposites so that when you add, the y's will drop out. Won't they? Is that good? All right. Okay. So there we go. 2 equations, 2 letters. Same kind of thing. So let me make a suggestion. I mean, you could do it either way. How about this time? You know we got to make opposites, right? And we either got to make the x's opposites or the y's. It'll work either way. How about we do the x's this time? How about we make those x's opposites? And then we'll add. So what does that mean? What am I going to make that top end? Right now, what's there right now? There's nothing there, which means 1, invisible 1. There's a 1x, right? So what do I have to multiply the top by to make these guys opposites?
-4.
-4. So go ahead and multiply through the top equation by -4. Give you a second. Let's look at, what's the name of the game again? We want to make either the x's or the y's. It doesn't matter. I said, hey, let's do the x's this time. Opposites. Opposites, right? Like 4 and -4. I want to make them opposites. So I'm going to take that 1 and multiply by -4. -4, -4, -4. Is that making sense? Why am I doing that? Because I want to make these guys opposites, -4x and +4x, so that when I add them, they'll be 0 and gone. Eliminate, right? Good? So now what do? Well, bring them both down. So that top one, come on down and write what you've got. -4x, -8y, +12. Watch your signs really carefully. Encourage you, make your negatives big. That way you won't tend to miss them. And then the bottom equation, I'll just bring it down unchanged. Is that good? And then add them up. Let me let you do the next. So we add them up. The x's cancel. We made that happen, right? And we get -3y is -3. So then what do we do to get y alone? Divide. We always divide by exactly what's next to the letter, huh? Divide by -3. In both cases. Cancels. Y is +1, right? 2 negatives make positive. Again, watch your signs carefully. Most mistakes are little bitty negatives and positive stuff. Okay, so we got y equals 1. That's half the battle, or a little more than half probably. And now we're going to go back and say, okay, take that answer, bring it up here, plug in y equals 1. Plug it in where? Really wherever you want. I'll just grab that first equation. So grab that first one, bring it over. 1x plus 2y minus 3. You good there so far? So I'm going to take that 1 and plug it in right there for y. All right, and so then what do we got? 1x plus 2 times 1 equals -3. That's x plus 2 is -3. X is saying I want to be alone, so you know the drill. Subtract 2 from both sides. X is -5. Makes sense? So then our overall answer is x, comma y. It's always x, comma y. There's what they want. -5, comma y. It's always x first, then y. How are we doing? How many got that at the end there? Got that right? So about maybe 2/3 of you. That's good. Questions I can answer on that? Good. Let's try another one, huh? Okay, so there's number 4. Same kind of thing. We gotta make into the x's or the y's opposites. Do either one you want. You gotta make them. You gotta make the 2 x's be the same number, one positive, one negative, or you could do the y's. It doesn't really matter. Make the 2 y's become the same number, one positive, one negative, opposites. In other words. All right. So go ahead. I'll give you a chance to do that. Okay. So again, the deal is, we look up here and we say, what can I multiply the 3x by to make it the opposite of the 6x, negative 2? It's become negative 6x, right? Okay, so I'm going to do that. So negative 2, negative 2, negative 2. We've got to go all the way across, equal treatment, right? So we don't change the equation. Same thing to both sides. Okay, so bring it on down. What do we got? Negative 6x. Negative 4y, right? This is negative 4 right here. 2 times negative 2. And what's negative 2 times 0? 0. Anything times 0 is 0. Bring down the second equation. Unchanged. Good? To there? Add them up. So there's the x's. They cancel. That was our plan. No surprise there. But look at this. The y's also canceled. We didn't really plan for that. Equals 6. 0 plus 0 equals 6. That's not true, is it? So guess what that means? So notice there's no x and no y. Both have vanished. Yeah, it's no solution. This is a no solution problem. No solution. So let me write a note, because sometimes something weird will happen and it's actually infinite solution instead of no solution. So you got to know which is which. Basically, here's the deal. If x, well, yeah, let me write a statement up there. If x and y both cancel, and then you get like 0 plus 0 equals 0, that's infinite solutions. Whereas if you get like 0 plus 0 equals, some number, like 6 or 5 or negative 3 or whatever, then that's no solution. So there's two different cases. Good to put that on your 3x5 card for the next exam. When's our next exam? Is it Thursday? I'm just kidding. It's not Thursday, is it? It's next Thursday. Next week on Thursday. So we got a week and 2 days still for exam 2. Anyway, so you want to have this on your 3x5 card. 0 plus 0 equals 0 is infinite. So, and 0, 0 number is no solution. So 0 plus 0 equals 0 is a true statement. So we'd expect there to be answers there. We good on that? Yeah, Carlos.
So why do you pick only 3x5 cards instead of like 8 by something?
Okay, so there's number 5. So I'll let you copy it down and think about what to multiply by. Take a look. If I was to, we got to make opposites, right? Either the 2x's or the 2y's, we got to make them opposites. Now, when you look at the 3 and the 5, that's not easy, right? I could make them opposites, but I'd have to multiply them by the other number. You can always do that. Do you know what I mean? If I multiplied the top by 5 and the bottom by 3, then that'd make them both 15, wouldn't it? You got to do one of them negative, so maybe the top by negative 5. Then that would make the top negative 15x. And the bottom positive. And you have to go all the way to negative 5, negative 5, negative 5, 3, 3, 3. You have to go all the way whenever you do it. That's a lot of work. You could do that, though. And they might make us do that in some of the higher problems near the end of the section. But rather than do x and make those both into 15, which you could always do, how about we do the y's? The y's are a little bit easier, aren't they? Let's look at the y's. What could I multiply that negative 4 by to make it the minus 4y by to make it the opposite of the plus 8y? 2. So I would just go ahead and do that. That way you don't have to multiply both equations. We might have to at the end, problems 11 or 10 and 11 or whatever. So I'm going to multiply through by 2, 2, 2 on the top equation. Right? 2, 2, 2. So take it from... Okay. So I'll draw, put my line, and then I'm going to bring them down. So bring this one down. This is going to be 6x minus 8y is 20. Good.
Oh, yeah.
And then bring this one down. 5x plus 8y is 13. add them up. We good? And now what's going to happen? 11x, the y's cancel, 33. And then we get x alone. Divide by 11. X is 3. So now we got x. Whenever we get x, we go back to plug it in. So we take that x of 3, bring it up here, and plug in x is 3. Is that good? We're doing okay there. So when we plug in, where do we plug in? What's that? Yeah, really any of them. You can plug into any of those 4 equations. It'll work in all of them. So I'm just going to grab the top one. That's what I usually do. I just grab the top one. 3x minus 4y is 10. Like that. I just grab the top one. Grab the 3 and plug it in for x. Because it's x is 3, right? So then we get 3 times 3 minus 4y is 10. We good so far? And so what's that going to be? That's going to be, what? 9 minus 4y is 10. So we go to there. Y is saying, I want to be alone, like they're always saying. So what do we do to get y alone? Minus the 9 from both sides. These cancel. We get minus 4y is 1. Last step to get y alone is divide. Divide by exactly what's next to the letter. Same sign, same everything. Negative 4. Boom, there's y. So the answer is 3 for x, right? X always comes first, then y. 3 comma negative 1/4, that's x, y. With the parentheses and the comma. We good? On that one.
Is it acceptable to answer the one with the decimal?
No, I think they want a fraction. I'm pretty sure they will require a fraction. I can go back and look real quick. Okay. So let's try that one. So, same game plan. Got to get x or y to cancel. Why don't we, just so we're all on the same page, why don't we get, what do you guys want to do, x or y? Y, okay. Why don't we get y's to cancel? You could do x, it doesn't really matter. So let's make the y's, we'll start with the y's anyway. Let's make the y's opposites. You can do x's, there's no rhyme or reason. They're about equally difficult. One of them a positive 30. Be super careful with your signs. Now, so I'm gonna say, okay, look, if I multiply that top by 6 and that bottom by 5, see how that'll make both those 30? So this time, we have to multiply both equations. I think it's the first time we've had to. See, that'll make a negative 30 and a positive 30. But then, you're right on, Carlos, then we got to go all the way. We got to go 6 all the way across the top. And 5 all the way across the bottom. All right. Okay, so, right, so these are getting messy. It'll help you to kind of keep things organized if you can. That's part of the deal. Math is a messy subject. Got to keep it organized. All right, so bringing it on down to here. Right, so see how I put a line just to kind of separate things, keep it organized. So what do we got? 30x minus 30y is 5 times 6, 30. Okay, and then see how I draw arrows? I'm showing really clearly the top one comes down, the bottom one comes down, you know? So, because I just know it's so easy to mess up. Plus 30y, and what's that, 90? And now we add them up. And we made the y's cancel. This is 60x. What's this? 120. Last step, divide by 60. X is 2. So we got an answer for x. take that on up now. So x is 2, bring it up here. Plug in x is 2. Where are we going to plug it in? The first, for any equation you want, let's always grab the first one. So 5x minus 5y is 5. Plug in that 2 right there. So we get 5 times 2 minus 5y is 5. So what's that? 10 minus 5y is 5. And all right, so there we are, and y is saying what he's always saying. I want to be alone. So subtract 10 from both sides, like that, right? Boom, like that. Minus 5y is minus 5. Last step. Divide by minus 5. Y is positive 1, huh? We good? So what's the overall answer? 2, 1, x, y. That's a funny problem? We good? Questions I can answer?
Yeah.
All right. Okay. So let's try that one. Same game. We're going to have to make either the x's or the y's be opposites. How about we do the x's this time? Did the y's last time. So you can do the other one if you want to. But when I do it up here, I'm going to do the x's. I'm going to make the two x's become opposites. So if you want to track with my work, go ahead and do the x's. It'll work either way, though. All right, I didn't realize, okay, we have a fraction one on our hands. All right, so here we go. So we need to make the x's or the y's. I chose to do x's opposites, right? So I got to make both these x's become something. What could I make them both become? 10, right? You multiply them together, it's 10. So I'm going to multiply them by the other guy, right? To make them both 10. You got to make one of them a negative 10. Doesn't really matter which one. I'll just do the top by 5. I could do negative 5. And I'll do the bottom by negative 2. You just got to make one of them negative, one of them positive. Doesn't really matter which one. Good so far? It's making sense? Okay, now bring it. See how I draw a line? I bring the arrow, bring it down. So what do we have? 10x minus 55y is 35. So far, so good. And now the second one comes down. Minus 10x plus, watch your signs carefully, plus 10y is minus 14. Now, if you did the opposite signs, you might have, opposite of me, but it'll be the same in the end. Okay, so now we're going to add them up. See how that made the x's become opposites? So they cancel. That was our plan. Right, we made the x's opposites, so they would cancel out. So now what do we have? Minus 45y, 10 minus 55. Watch your signs carefully again.
21.
And this is 21. Good? All is well? Now, last step is always divide by exactly what's next to the letter. Same sign, same everything. So divide by minus 45. Boom. And so y is, now all fractions, need to be reduced, huh? If they can be.
7/15.
Yeah, divide by 3, huh? Top and bottom would be 7/15, but it's negative. It doesn't matter where you put the negative sign. Top, bottom, front, it's all the same thing. If there's a negative on a fraction, it's just negative. Doesn't matter where the negative is. I'll just put it in the front. I don't know if you know that. You wear that? With a negative on a fraction, doesn't matter where it is. See, it was in the bottom. I just pulled it to the front. Whatever. It's all the same thing. So we got y, negative 7/15. Yeah, that's ugly. Okay, we good so far? Everybody okay to that point? Now, when your first answer is a fraction, that's too bad. Because what are we going to do now? We're supposed to take that thing and plug it in, and I don't really want to plug in a fraction. Right? That could be painful. So, what?
Okay, but if the fraction is close to the divider, there's a 15, you plug it in the second because it has 5s and 15, you know,
That'd be a little better, I agree with you. It's still going to be messy though.
yeah.
Because if that was a nice 15, you know, yeah, then that'd be great. And I see what you're saying, and you're right, but it's still going to be painful. So I have a suggestion. You understand the dilemma, first off? I'd rather not plug in that fraction. So let me write that out for extra clarity. When your first answer is a fraction. When your first answer is a fraction. First off, you know, really, when your first answer is a fraction, you should check your work. Because that's not usually what happens. Usually the first answer is nice and clean. But every now and then, it does become messy, right? So when the first answer is a fraction, check your work. But if it's all right, and you're like, no, everything's right, that's really the answer, then what are you going to do? Instead of plugging in a fraction, because that's painful and you got fractions everywhere, instead of plugging in the fraction, there's a way we could avoid the whole fraction thing. Instead of doing that, think about this for a second. Have you noticed that sometimes we get y first and sometimes we get x first? Let's look back for a second. So we got y first here, and then we're trying to get x next. Look back at the last one. Yeah, the last one. Say we got x first on the last one, and then later we got the y. What is making that happen? Why sometimes are we getting x first, and sometimes are we getting y? What's causing that to happen?
The elimination of
Yeah, it's
X
who
or
we
Y.
eliminate. Yeah, because on this last one, number 6, we got the y's to eliminate first right here. The y's dropped out, so we got x first. But on this one, number 7, we got the x's to eliminate first, so we happen to get y. Do you know where I'm going?
Adding.
So when the first answer is a fraction, instead of plugging in, because we want to find the other letter, right? We got y, we need x. Instead of plugging in a fraction, which is terrible, restart and cancel the other letter. That's going to be easier than dealing with fractions. Just restart and cancel the other letter. I mean, you can plug in the fraction if you want to, but it's pretty painful. So I'm just going to restart, and this time, instead of getting x's to cancel,
We cancel the Y.
we get the y's to cancel. We'll never have to touch a fraction. Which is kind of my goal in algebra, is to avoid fractions at every turn. So let's restart. So 2x minus 11y is 7, so I'm going to redo it. Was that 2x minus 11y is 7? Okay. 2x minus 11y is 7, and 5x minus 5y is 7. Okay, so this is number 7, the restart. So this time, instead of getting the x's to both become 10, or one of them be a negative 10 and the other positive 10, I'm going to get the y's to be the same number. Opposites, really. So, multiply them together, right? 55? So I'm going to make both those y's become 55. One of them, though, needs to be a negative 55, and one of them a positive 55. It doesn't matter which one.
Okay, so the bottom by 11, the top by
Exactly,
5.
exactly. But you got to do one of them negative, don't you?
Yes.
So let's
Let's say
how about we do the top by 5
by 5.
and the bottom by like negative 11.
Minus 11.
See how that'll work? Is it like minus 14/15? Minus 42 over 45, and then you reduce it?
45.
Yeah, which reduces to minus 14/15, I think. So bring down the top one. And that'll be what? 10x minus 55y is 35. How we doing? This making sense? And then the second one comes down minus, what's that, 55? X plus, right, 2 negatives. Watch your sign. Make your negatives big so you don't lose them. 55y, and this is minus 77. And now we add them up. What's that going to be? Minus 45x. The y's drop out. Minus, what's that? 42. So that 42 is minus, right? 35 minus 77 is going to be negative. So then two negatives, positive, right? So last step to get that x alone, we divide by exactly what's next to x, huh? Same sign, same everything. Negative 45 on both sides, gonzo. And then we just reduce that fraction. So divide top and bottom by, what goes in there, 3? And that's going to be positive 14/15. So the answer is a fraction, but we never had to like mess around with it. We never had to cross cancel or common denominator or any of that stuff. The answer is just a fraction, and we didn't have to deal with it. So what's the final answer to the problem? That's x 14/15, and y we had on the other screen. What's that? Negative 7/15. We're done. 2 fraction answers, never had to deal with them though. So you see the way we avoided fractions there? We basically just did a restart, got x to eliminate one way, got y to eliminate the other. Pretty long problem, huh?
But then how do you double?
Yeah, but
Oh, you don't. It'd be terrible. I mean, it'd be real tedious. Yeah. Question? Comment? Manuel?
yeah, but
That's
both,
XY.
both have 15 on the bottom, so it like it makes sense. I don't know.
They don't have to, though. They could have different denominators.
They can have different.
They can.
and it still be wrong.
Yeah, right. Well, you know, earlier we had like one of them was a whole number, like 2, and the other was minus 1/4, remember? So one of them was not even, one's a fraction,
Yeah.
one was not. Yeah.
A mix of fractions and integers.
Yeah, whole numbers, yeah. Good, yeah, question?
Why is the answer positive?
Yeah, because of 2 negatives.
Also, when you're dealing with 2 negatives like that, it'll be
Yeah, 2 negatives multiplied or divided is positive.
They become.
Yeah, right. Whereas if you add, subtract 2 negatives, that makes a bigger, or add 2 negatives makes a bigger negative. Yeah. We good on that one? Questions on that? So that's pretty challenging there. Okay. So what are we going to do with this thing? Well, the problem starts with fractions. So we are going to take them out. Exactly right. Exactly what we're going to do. So when it has fractions in there, we need to eliminate those fractions, don't we? We need to eliminate. Yeah. So let me just write a note. When it starts with fractions, multiply all terms, every term, by the denom. So I'm going to multiply through all the terms by the denominator. What does that mean? That 3 there. See how that 3 is the denominator? Now, right now, I'm not even thinking about making the x's the opposite ways. I'll get to that later. My first order of business is I don't like fractions. And I want that thing out of there. So that's all I'm doing on this first step is just getting rid of that 3. So I'm calling the hitman, right? Take it out kind of thing. So 3, 3, 3. And that cancels, doesn't it? Let him do his job. Let him take out that denominator. So then what do we get? 4x plus 18y is minus 18. And the second equation, so there's the first. The second, I'll just bring it down, no changes. So is that good? Now we have no more fractions, right? See how that got rid of the fractions for us? So I'll let you take it from there. So yeah, so when we look at this, like you can look at the x's or the y's, doesn't really matter. Also look at the x's, and now we're like, okay, gotta make them opposites. That's what we're always doing, right? Now that we got rid of the fraction, make these opposites. That means multiply the bottom by -2, right? So it'll be -4x and positive 4x. They'll be opposites and cancel. So let's do it. So -2, -2, -2. All right, so what do we get? So bring down the top. The top equation has not changed at all. The bottom, kind of running out of room here. The bottom will become -4x minus 18y plus 18. Watch all your signs really carefully. Don't drop any negatives anymore. Make them big and bold. That way you won't lose them. Good. And now, add them up. When you add them up, gonzo, 0 plus 0 is 0. Remember what that means? Infinite. So it's not no solution, it's infinite. That means there's actually an infinite number of solutions to this system of two equations. We'll talk later about what those are. Those are actually, we're going to graph them later, and they're two lines. We'll see it later. Preview of coming attractions. But for now, we'll just say it's infinite for some reason. What it is, it's two lines that are right on top of each other that intersect in infinite points. That's what it is. Graphically, we'll see that later. Each of those equations is a line. And they're infinite because they normally two lines intersect in only one point. But these two lines are right on top of each other. Infinite solutions. And the no solution case is the two lines that are parallel don't hit at all. That's what's going on behind the scenes graphically. When we go back and pick up chapter 3, graphing, then we'll know how to graph lines. Then we'll come forward again and show how this is really what's happening here graphically. That's the master plan. All right, is that making sense though for now? Is that good? All is well? Questions? Okay. So this one, they're just kind of messing with us. They're just kind of putting X and Y in funny spots and seeing if we can handle that. Basically, the first order of business on this problem is to get things lined up. X's, then Y's, then numbers. And then it's normal from there. So first, get X, Y, numbers. Get them in that order. X, then Y, then numbers. Is that making sense? So go ahead. You want X, Y, equal sign, numbers, don't you? You want it in that order. You want X's and Y's on the left side, numbers on the right, don't you? So what do you do when you've got any number in front of parentheses? Yeah, it's going to multiply both those, and it's going to be -4 times x. So that's -4x. And -4 times -2, which is +8. And then just the 3y. So far, so good? The parentheses drop off, don't they? Are we good with that? Whenever anything is right in front of a parenthesis like that, it's like water up against the floodgate. The walls come down, the water rushes in, hits it. Right? We good there so far? That's distribution, multiplies both of them. Okay, now, do you see how the second equation is in good shape? It's x's, then y's, then numbers. That's what we like. That's what we want. That's what we've been doing all night. X's, then y's, then numbers. See how this equation, these two guys are in the wrong spots? See how they're out of order? You want to bring this 3y over here, and you want to bring this 8 over there. Because you want x's, y's, numbers. That's what I'm saying. They're giving it to you out of order. So you got to swap them. Now, what happens when you jump something to the other side of an equal sign?
They switch signs.
The sign switches. Are we okay with that? The sign in front of it changes. If it was positive, it becomes negative on the other side of the equal sign. If it was negative, it becomes positive on the other side of the equal sign. You know that? So So what does that give me then? That becomes minus 4x minus 3y, and the 8 is negative on the other side. Now it's in the right order. Now we got it. And at this point, we're ready to just bring down the second one, which has been good all along. Now we're ready. Now it's normal. Can you take it from there? All that preliminary work was just to make it like a normal problem. Everybody tracking with me on that? So now they're both, now see how they're lined up now real nice? X's with X's, Y's with Y's, numbers with numbers. So now can you take it from there? So now make the X's opposites or the Y's, whatever looks easiest to you. Give you a moment to do that. Anytime you can jump something to the other side of the equal sign and switch signs. Yeah?
Can you do that on the test?
Do that on the test?
Yeah.
Yeah, it's true. It's
Oh, you can still do it?
on like a test we take in here, you mean?
Yeah.
Yeah, well, I wouldn't be showing you anything that's false.
Oh,
Like I wouldn't be saying, hey, this works here, but don't do that on a test. No, it's totally fine. Yeah, absolutely.
it's not skipping anything or nothing?
No, it's okay. Just a little shortcut. Yeah, it's totally fine. Yeah, at any time you want. That's when you jump over the equal sign, though. Right? You with me on that? It's because I jumped over the equals that the sign changed. Right. So, whereas if I was just, what I mean is, if I was just to move these guys around here, not jumping over the equals, nobody's sign is going to change. It's only when you jump over the equals that the sign changes. Yeah. No, that's fine to do it anytime. Okay, so now we're going to make those opposites. So I'm going to make this a plus 4x by multiplying through by 2. So let's do that. So 2, 2, 2, all the way across like that. And so then what are we going to get? So I'll bring down that top equation. Unchanged. Minus 4x minus 3y is minus 8. And then the bottom equation, 4x minus 4y is minus 6. Can you read all that? Kind of running out of room down there. Yeah, let me squeeze that in. I'm just terribly running out of room here. So I'm making those opposites. So let me do that again. So plus 2, plus 2, plus 2. And then the top equation, minus 4x minus 3y minus 8. The bottom equation, 4x minus 4y minus 6. Good? And see how we've made those x's opposites, haven't we? These x's are opposites. So we can add them up now. And the x's cancel. Get minus 7y minus 14. Right, minus 3y minus 4y is minus 7y. We good there? Makes minus 14. I'll bring it up here. So I've got minus 7y minus 14. Last step to get y alone. Divide by exactly what's next to the letter. Same sign, same everything, huh? So divide by minus 7. And y will equal positive 2, a regular 2, huh? Because two negatives make a positive there, huh? Two negatives make a positive. So all that work, and we only have y. How do we get x? Plug it in somewhere. I'm going to grab, what am I going to grab? I don't want to grab that first equation. I don't want to mess with that thing anymore. So remember, you have your choice. You can use any equation you want. So maybe I'll just grab the second one. It looks a little easier to deal with. You hear what I'm saying on that? So you can use any equation. You don't have to go back to the first. I don't really want to. So I'm going to grab the second one. 2x minus 2y is negative 3, and plug in the 2 right there for y. So that'll be 2x minus 2 times 2 equals negative 3. Okay, there I'm kind of running out of room on that one. This is a long problem. Okay, and so then that's what? 2x minus 4 is negative 3. This problem is almost over. Keeps going and going. So then add 4. 2x is 1. Divide by 2. There it is. Whew. X is a half?
Half, yes.
Did you get that after all that work? So y is 2, x is a half after all that work. Is that good? Is that okay? These are not easy questions. Questions on that one. So what was weird about this one? So from the beginning, we had to reorganize the top equation. Right? We had x's on the left, y's, bless you. We had to get the x's and y's on the same side. So you just jump things over the equal sign, and it switches signs. So if they ever give you anything like out of order, not organized, just jump things over the equal signs, and they switch signs, and you can get it all organized. How we doing? You good? You got 15 more minutes in you? Are we good? All right. Okay, there it is. All right, so there it is. Let me give you a second. So we're going to call the hitman. So for the first, it's just 5, right? Because the first equation just has a couple of 5 denominators. That's just 5. No big deal there. Now, let me do it wrong. Let me play Mr. Heron does it wrong, and you tell me what I'm doing wrong. Multiply by 5. Multiply by 5. Yeah. Got to do all of them, right? Equal treatment. No playing favorites. So you gotta put a 5 there as well. Right? All the way. Equal treatment. All right? Here, let me that's mistake number 1. I could write a laundry list of these after 25 years of teaching algebra. Here's the next mistake. You ready? Bring it down. 5 times 9, 45. Minus 5y. 5 times 8. Over there, 5 times 8. 40. Wrong again. What did I just do?
You didn't run everything.
I just ruined everything. I called. Why do I make up that weird word hitman? Why am I doing that? I'm not just trying to be funny.
To simplify everything.
To make you think of an action. What does a hitman do? He kills somebody. I didn't kill anybody there. So that means I'm doing that so you remember, oh yeah, I'm supposed to cancel something. Right? Boom. I'm even making sound effects. Boom. There it is. So that's 9x. And over here, boom. See, he's got to cancel. Let him do his job. Let him take something out. That's the other mistake I see a lot. Good. Now it's right. Now, can you do the second equation? For the second equation, you have 2 different denominators that we need to take out. So what do you do when you have 2 different denominators? Multiply them together. 2 times 5? 10. 10, 10, 10. So do that one now. So now we're going to do 10. And right now I'm not trying to make anything same or opposite. I'm just getting rid of fractions right now, right? So go ahead and do the 10, 10, 10 thing. That one's a little trickier. See if you can do that one. Okay, so when I do 10, 10, 10, all right. Now, that'll be 30x. And what will happen there in the middle? He'll take out the denominator. That's why I keep calling him Hitman. He takes something out. Don't forget that and just write 10y. I do that because I've had thousands of students write 10y. And it's not 10y, right? It's just going to be 5y, isn't it? Because 2 goes into 10 5 times. What's going to happen on the other side? Same thing. Take it out. That's why we're doing it. We want to take it out. And then 2 times 9, 18. The leftovers multiply, don't they? Do you see that? Right, good. $39x, the y's cancel. What's that, 26? We good there? Last step for solving for x there is to divide by 39. Like that. We good there? Now, what do we do with a fraction that's not reduced? We reduce it, huh? So I'm going to divide. You know what goes into both those? Oh no, we don't want a decimal. We want a fraction.
It's 2/3.
It is 2/3, yeah. Because you can divide top and bottom by 13. It's 2/3. X is 2/3. Okay, so x is 2/3. Now, 2/3. So what do I got to do with that 2/3?
Put it on the side, and then we go back for x. I mean for y.
You mean like, yeah, we could do the restart thing. I think 2/3 is not too bad of a fraction. It might be easier just to plug that one in. You can do it either way you want. Yeah, I don't know if, I hope I'm not confusing you here. Basically, anytime you want, and when you get the first answer, if you don't want to plug it in, you can always restart. That's always an option. I think 2/3 is not too ugly of a fraction. I think it would actually be easier just to plug it into 2/3 than doing a full-fledged restart. So I'm just going to plug in the x's. If I had something ugly like 2, 19ths or something, I know that's ugly. I'm just going to restart. But 2/3, not too bad. And look at these x's. Like Manuel was watching 9 and 30. They're going to cancel that 3. It's going to be pretty clean, really. So now, where do I plug in? I'm going to take that and I'm going to plug it in. Where do I plug in?
In the bottom.
Anywhere you want. Everybody catch me on that? I always get that question a lot later. Mr. Do we have to plug it to the top? I don't want to go back to that ugly fraction stuff. No way. I'm never going back there. Even if I was going to do a restart, I would restart from here. I'm never going back to the fractions. Remember, these are all equivalent. You can work with any of them. They're all the same. So why bother with fractions? I'm going to go back to like one of these two for my plug-in. So I'll say, okay, so I'm kind of out of room. I'm going to grab this one and go to the next screen.
The 9x?
Yeah, so the 9x minus 5y, what is it? Equals 8. And I'm going to plug in, what answer we get? X is 2/3. So I'm going to take the x is 2/3. And I'm going to grab that and I'm going to plug it in right there. So then we'll get 9 and then the parenthesis 2/3 minus 5y is 8. Okay. Now, do you know, can you solve it from there? Let me give you. Yeah, so what happens here? Whenever you have a whole number, like 9 interacting with a fraction, you put it over 1, huh? So make that 9 over 1. And then you cross cancel. 3 goes into 9. 3 times 2 is 6. We all good with that? So look at that. It's pretty clean, huh? The fraction goes away. Y says I want to be alone. You know the drill. Subtract 6 from both sides. Minus 5y is 2. Last step. Divide by the minus 5. There it is. There's y. So y is minus 2/5. So the answer is 2/3 for x minus 2/5 for y. That's x, y. All right, one more. There's the bell. We good to there? Questions there? We good? Number 11, decimals. So what should you do when you got a bunch of decimals? Yeah, that's a terrible question. Can we get rid of the decimals? Yeah, what gets rid of it?
10.
Yeah, like 10 or 100 or numbers like that, huh? Yeah, the top equation, all the decimals need to move 2 places, don't they? To get all the way to the right and just become whole numbers. So what makes a decimal move 2 places? 100, yeah. So you're going to take the top equation by 100. The bottom equation, the decimals only need to move 1 place, don't they? So I'm going to just multiply through by 10. 1 0 moves all the decimals 1 place. You tracking with me? So whatever decimal you need to move the most, that's how many zeros you need to use. 2 zeros, move it 2 places. So the decimal will go 2 places. This will become 6x, 2 places, 4y, 2 places, 5. Next equation will move 1 place, minus 1x, 1 place, 5y, 1 place, negative 15. Not making sense there? Much cleaner, huh? No more decimals? No more decimals, that good? What would be the next step on this one to cancel something? What are we going to do? Exactly. Right? Is that making sense? Because you want to make those x's be opposites, huh? So you would multiply the bottom by 6. I'm just going to do that and go dot, dot, dot. Right? Dot, dot, dot. You've done a bunch of them already. You know what to do from there. Right? That'll make those x's opposites. Add them up. They'll cancel. You'll get an answer, whatever it may be. I have no idea. From there. Is that good? I'll stop it from